It is such an honor to be here to have the opportunity to share my research with you today. I'd like to talk a little bit about how the issue of language affects student assessment in chemistry and really in any introductory science classes. So I'm going to just jump right in, and I'm going to show you a sample exam question. And I took this from an old exam in general chemistry, and this is one of the questions that students actually do get to see. I'm talking about freshman level. And so this is something they get to see. So I want you to look at this from the perspective of somebody who doesn't have a fully developed English language proficiency. So if you're looking at this on an exam, this is kind of how you would read it, right? You're like, well, there's something happening with ethane, blah, blah, blah. I don't really know what those words mean. I guess I'll keep going, and I have to calculate something, and the reaction is doing something. So that's pretty much how students experience, like reading these complicated sentences and this high level of technical vocabulary. But even as somebody who speaks English fluently, it's still quite a lot of information for students to process on an exam. So they'll give you a little bit of information about ethane, and then they talk about the formation of other byproducts, and then they're asked to calculate theoretical yield, percent yield. Still, again, a challenging question. So as you can imagine, if you are a student who came and you don't really understand all of what was asking, it's still a very, very different experience for you to take the test. And so this issue of language proficiency, I believe, is crucial to assessment. In fact, it's so important that some believe that language plays an integral role in most, if not all, academic learning. And any testing of academic achievement is also, to some degree, a test of language ability. So really, if we're really trying to test somebody's chemistry content knowledge, we really need to understand their language ability as well. So this is generally the cognitive process that people use to solve word problems. So you read the question, and you identify the key information in that question, and you solve the numerical computation, and you connect chemistry contents. If you are still in the process of developing your language fluency, then you have a few additional steps to take. So in addition, you have to translate to your L1, your first language, your native language, and you have to form an interpretation. And then you still have to do all the other parts, but then you have to transfer that knowledge back into English and formulate a response in English. So, I mean, it's not surprising that this causes cognitive overload. And, the consequences of their, long-term consequences are performance differences. Linguistic minority students tend to score lower, than to get lower grades in chemistry. They tend to get lower grades in really a lot of the introductory science courses. And then what we do see as a whole of this population is a persistent attainment gap. So just this first row on top shows bachelor's degree completion rates. So as you can see, only 11.7% of ELLs complete a bachelor's degree, compared to 31.9% English monolingual students and 24.6% English proficient linguistic minority students. So we're seeing a performance difference, and we're seeing how this affects higher education. And it really reminded me to think of what we was discussed earlier today in the keynote, and this affects upward mobility for these students. It affects how decision to stay in a STEM degree. It affects students' decision to, think maybe the STEM isn't for me, right? So this is an important number to think about. And then when I took a closer look at chemistry, I found that chemistry is probably one of the least diverse fields in the sciences. Especially when we look at racial and ethnic minorities that are, having a career in chemistry, and as well as the permanent citizen students. As you can see, it's a 69.8% Caucasian. As you can see, races like Black and Hispanic and Latino are disproportionately underrepresented in chemistry. And so it makes me think, what are we doing to turn away racial and ethnic minority students from chemistry? And is this feeding into diversity, inclusivity in STEM fields? Because chemistry is quite a gateway class. In general chemistry, at least, it leads to a lot of health professions, physical therapy, medicine, nursing. And so this is quite a gateway class, and this is the class where I feel like we could capture more diversity in our students. And so with that, I came up with my research goals. So ultimately, my goal is to deliver practical and applicable guidelines for creating more equitable assessments. And so what that means is it's a two-part study I conducted. The first part is, let me just collect data about what students actually find useful or not useful when they're looking at exam questions. And the second part is more of a generalizable quantitative study data where I'm looking for bias. Are certain exam questions biased towards subgroups of students? So I'm going to be using an analytical method called differential item functioning to look into that. Today I'm just going to be discussing the first part of that study, which is the identifying the features that students find challenging. All right, so this is what the data shows so far. So it shows that when students approach an exam question, these are the four main types of features that they look for. So we look for its macro structure. So even before students read a question, they already have some sort of reaction to the way this question appears on paper. Like, how does it look visually, spatially on paper? They've already made up their mind, thinking, oh, this is going to be quite difficult, or this is going to be okay, this is maybe more approachable. And then, the thing about readability. How easy it is to understand a sentence. They have complicated run-on sentences. What about the syntax? And does it have visual representations? Scaffolding, does it have guidance within the question? Are there clues to how you can solve the question within the question? So I'm going to show you one of the questions that we used in our study. Again, this has been used on exams before. So again, this is general chemistry. This is the topics of limiting reactant and percent yield. And it gives you a little bit of a background about what methyl alcohol is. So you get a little bit of background, and you talk about how it's manufactured, and then their students are supposed to figure out how to calculate its theoretical yield. And then using that theoretical yield, they're expected to figure out percent yield. And so I asked the students, we had equal amounts of ELL participants as well as monolingual English students. And so we asked the students to go through and identify some challenging features to this. So immediately was just the whole macro structure. Like, this looks like a chunk of paragraph. We don't even want to read it. Like, this is way too much to read. It's overwhelming. So this is one of the quotes from one of our ELL students, Asha. He said, well, for me, you won't really know where at first to start. They just give you a bunch of numbers, and it takes a while to figure out these numbers from this number, and this molecule, and then this one's it's just hard to organize it. You actually have to work on it before you really work on it, or else you'll forget the details. So remember, these are timed exams. They're usually 50 minutes, and they have 25 usually questions to solve in general chemistry. And so this is quite a lot of information to process in just one question. Furthermore, background information. So I'm guilty of this. I like to include fun facts and things like that about chemistry in my background. Turns out, yeah, students are not loving that, right? So this whole information about, how can we use methyl alcohol? Students are like, well, why do we need to know that, Dr. Lee? Do we, are you asking us questions about, how to manufacture that? No, you're asking us to solve a mathematical computation about a reaction's theoretical yield. And we don't really need to know that information right now. And so here are some of our students. So Alara, I would remove the fun fact that methanol can replace gas just because I don't really think it helps with calculating your answer. Magdalena, yes, take this part out. It's fun to know these little fun facts, but I mean, in an exam, cool, but I don't really need to know this. All right, so this is a way where we can improve write the way we write our questions and focus on the information they immediately need to solve the question instead of providing more fun facts like I used to do. Readability was also one of the things they found difficult. So there are, words in this question that make it unnecessarily longer and complicated. So considered to be potential replacement, manufactured, suppose. We understand these words. However, students recognize that these are sort of elevated words and they're not necessarily needed. They're not specifically chemistry vocabulary that had to be used to understand the question. And so, as you can see in Felipe's comment, like potential and manufactured are words that are sort of, especially because some of this information is not super needed when it's talking about being the simplest alcohol. And so why not just use is the simplest alcohol, or instead of manufactured, methanol can be used by combining gaseous carbon monoxide. So we can further simplify this without diluting the content difficulty of this question. This is another thing that was difficult. So we as professors like to give a lot of information in one sentence. And I know so many people who like to start a question with if you have certain amount of this and certain amount of this, then calculate something. And so this is something that is especially like difficult for even English language learners, but especially English, all across the board, it was difficult for students to understand. So this person, Zuri, says, I feel like some of my chem questions are like this because this is when it starts to get hard for me, because when I have so much information to sift through, I don't know what I'm looking for. Finally, we asked for what things are good about this question. What did you actually like? What helped you solve the question? And the only things they came up with were these elements. So they liked the fact that chemical formulas were given right next to the name of the compound. They liked the fact that what is the percent yield of methanol is a straightforward, simple question that really anybody can understand. So, and this person, Anastasia, she says, so I like this. I noticed that the part where they talk about the task is broken up into much shorter sentences for all of the background information. So I think that part is good just because you have some processing time in between sentences. All right, so then we modified it. So I'm using a conceptual framework to modify and linguistically simplify each of these assessment items. So I modified this and I took out unnecessary complicated vocabulary words. I simplified the sentence structure, the syntax. I reduced non-essential words. And as you can see, there's a glaring difference here. So the part where methanol is made by gaseous carbon monoxide, that part is still there, but you can see there are 2 bullet points. Now it's visually, spatially, you can see the parts with it. A lot of students didn't realize that this was actually asking for 2 questions or 2 answers. And so when I showed them this, they realized, oh, so you are asking for 2 different answers to this question. So this made it a lot more clear for students. So we asked, again, what are some difficult things here? And they didn't really come up with a lot of challenging features of this item, but they did talk about some of the helpful things. So the macro structure, how it looks visually, spatially, that's something they immediately picked up on. This was considered to be more approachable. Some students actually thought it was easier to solve, which it really wasn't. It was the same level of content difficulty. It was just perceived as to be easier to solve because of the way it's been organized. They appreciated the division of parts, and this word actually prompted them to think about the equation you need to calculate the actual yield. So that was one of the ones that give them contextual cues to the question. Simple sentence structure, what is the? Instead of if and then, instead of run-on questions, this was quite easy for them to understand. So, comment from Fujin. This one's much better. It's neater and you know which steps you need to take. It's much easier to understand because you can distinguish between which is the background and which is the main sentence. Then the bullet points tell you which parts you need to do, and then there are 2 steps to the problem. So they got it right away. And actually I saw a performance difference. So I randomly presented this version and the original version to participants. A lot of the participants didn't even complete the original version, but when I presented this one, more of them got it correct. Although, again, it's the same content level difficulty. So that was pretty exciting. Okay, so here's a comparison back to back of these items. And we always give them a choice. We're like, now you've seen both versions of these items in some way or form. Which one would you prefer to see on an exam, right? Every single participant so far has picked this one. We have now about 60 participants. And so all 60 have picked the modified version of this. In the modified version of the item, more and more students are getting it correct. More and more students are able to demonstrate what they know just because of linguistic simplification, not because they know more chemistry or they know less chemistry. The content knowledge is still there. All right, so I have a few guidelines for educators about how to write more accessible assessment items. So again, as you've already seen, shorter sentences, taking out non-essential vocabulary words, keeping things visually, spatially oriented, using an active voice, organizing data, using a data table or bulleted lists. So things like that. There's much more to this than this, but this is all I can fit on the slide. So incorporating more simpler elements like this really go a long way. All right, so what are the broader implications of this research? So this research has been funded by the National Science Foundation. So really fortunate to have funding to advance this research. And so what I envision seeing is that this is effective, and using linguistic simplification is actually advancing our knowledge as educators on how to assess students in a more inclusive and equitable manner. And so this helps alleviate the burden, that cognitive load of language proficiency for ELL undergraduate students. But I've also noticed that it's really helping really generally all students. It's not just ELLs that are finding it beneficial. And again, it's part of the mission to create inclusive and accessible learning environment for a diverse body of students. All right, just wanted to shout out and thank my mentors, collaborators, and Dr. Elizabeth Wright, our chancellor, who's here, for asking me to be here and giving me this opportunity to share my research. And I'll take questions.
One of the things I see this applying to outside of teaching, as well as is conversing in English with people who speak English as a second language in the business world and also in engineering, to be very simple in what you're stating and organizing information in a very specific way to get your point across quickly, and also trying to get your point across or get answers to your questions that you're actually asking, not the ones you think you're asking. So it was very good to see the way you presented this. Is the paper, the study available?
Yeah, it's been published. It's in the Journal of Chemical Education. If you can find it. If you just look up my name. Thank you.
I actually have a question, because this was really interesting for me. Because even when you put that first question up, I know nothing about chemistry, but now I can really see the difference that it makes when you just put stuff that doesn't really impact the answer that you're looking for. What are the next steps to get this type of research out to other people? Because if, in fact, you're surveying that 60-person classroom, that impact could be really huge nationwide, worldwide. What are your next steps? What are you looking at doing and your team to get this research out there and in the hands of administrators to bring this to their own classrooms?
Excellent question. Yeah, as part of the NSF grant, we are required to hold workshops. So that's one of the things we're doing, is holding workshops at our, like American Chemical Society, some of our chem ed workshops, we are holding that. We're trying to publish in more well-rounded journals, not just chemistry-specific journals, because I really think this applies to a lot more disciplines than just chemistry. I mean, this is really applicable to really all introductory sciences. Even beyond sciences, I've been told that it's applicable. We're also our team is separating, we're trying to go to more different types of venues to present this information. But in terms of experimental design, we have a huge quantitative study coming up, and that's gonna have like 300 participants, and it's gonna be done across Penn State campuses, specifically the State College campus. And so with that, I think we'll have more generalizable data that shows more validity and reliability of this work.
We talk so much in higher ed right now about becoming a more equitable institution. We certainly talk about it at Penn State. How do you see research like this transforming higher ed in general?
I think baby steps. Research like this, if I can have my colleagues, my fellow instructors buy in to this idea of writing more accessible exam questions, and I think that will allow more students to understand what's being asked of them. That will allow students to demonstrate their true content knowledge, because so many times I've seen a student get a C on my exam, but then I sit down with her and I said, hey, I was asking about this specific process, the Krebs cycle, can you tell me? She knows way more than the grade that I gave her, right? And so this made me realize this is probably happening across the board. And so I think this encourages students to have, first of all, less anxiety. It makes them feel like this is a safe space, right? Like maybe I don't have to freak out every time I see a chemistry question on an exam. Maybe if it's structured in a more approachable manner, maybe, that way I can do a little bit better to improve my grades.
This is terrific research, and yeah, I think it's definitely applicable well beyond science. Have you thought about reaching out to textbook publishers?
I've actually been approached by textbook publishers. I haven't had a chance.
It's a lot of work, yes.
Yeah, it's a lot of work. I haven't had a chance to go into that area. I've been asked to look into it though.
Because I know a lot of instructors, especially in the online space, rely very heavily on that because of time constraints with the mass amount of students that they have. So
Yeah. So have you heard of OpenStax, right? And LibreTech. So these are open educational resources. I'm actually working in a collaboration project with them where I review the accessibility of the chemistry items they are coming up with. So that's a side project I'm working on.
Thank you very much for presenting this research. And you may not know the answer to this because it's not your intention to do a comparative study, but I'm kind of curious if this is a problem specific to higher ed, so that in high school, say, those textbooks are written in a more accessible way, and students think, oh, I might do science, and then they get to college, and it's like, oh, no, I can't do science. Or if, in fact, the problem is farther down, and we need to drive this kind of research not only in higher ed, but down to high school. And so I'm just curious if you have a sense of that.
Yeah, so I have let me go back to my team page. So in my research team, there is someone who, she's not currently working on my research, but she's a high school teacher. And so she really found this information compelling, and she says it happens in high school all the time. In fact, when they're under 18, that language proficiency part can be even more difficult sometimes. And so, especially when it comes to, sciences. So in high school, I know it's applicable as well. My background has been with undergraduate students, but that's an area I'm looking forward to exploring.
We're the only K-12 people here, I think. They're written at a college level in high school. So they're completely inaccessible to high school kids. They're not on grade level.
All right, that's going to wrap up this session. Thank you so much.
you.